Hello and welcome to the BluePlanet 5G automation demo. Network slicing is a critical component of the 5G architecture. Using network slicing, mobile network operators can dynamically create multiple unique virtual networks to deliver different types of services that are customized to meet the needs of different types of end users. In this demonstration, we will showcase BluePlanet's solution for zero-touch slice lifecycle management and automate the design, creation, modification, and monitoring of two different network slices from end to end across a multi-domain 5G infrastructure. The environment for this demo consists of a front haul, mid-haul, and backhaul transport network, which connects the virtualized RAN and virtualized 5G core domains, both powered by our demo partner Radisys. Finally, for zero-touch slice lifecycle management, we have the BluePlanet 5G automation solution. This intelligent automation solution is built on our multi-domain service orchestration or MDSO, NFV service orchestration or NFVO, and route optimization and analysis or ROA products. The demo is divided into three phases. As part of the instantiation and activation phase, we will begin with the instantiation of two network slices. One latency agnostic enhanced mobile broadband or EMBB slice, and one latency critical ultra reliable low latency communications or URLLC slice. Each slice will have their own dedicated RAN CUUP, which is the centralized unit user plane, and L3 VPN transport function. For the transport slicing in this demo, we are using layer 3 VPNs and segment routing, but can also support hard slicing. Both network slices will use a shared UPF, a user plane function. To do this, let us log in into our BluePlanet MDSO UI. As you can see, this is a greenfield setup where the 5G network slices will be instantiated. In our slice management and administration section, we can see there are no slices that have been created. So we are ready to create our first slice, which is done using this wizard. The first slice we will create is the latency agnostic EMBB slice. The BluePlanet solution supports both a single domain slicing as well as end-to-end slicing that is aligned with ETSI's Zero-Touch Service Management or ZSM framework. Here, we are requesting an end-to-end slice and thus all three domains, transport, RAN, and core are selected. We then move into the different components and specify their parameters. For this demo, we use parameters that are based on the GSMA Generic Network Slice Templates or GSTs for EMBB. After we click on Create, the orchestration for creation of the slice is now taking place in the background. We can see the slices for the core, RAN, transport, and so on are being created. The EMBB slice has been successfully created, and we can drill down to look at its details. There is the slice summary and parameters we've specified. Let us go back and see the lifecycle management of the slice. As you can see, we have completed the creation of the slice. The next stage is to activate it. Select Activation and click Apply. The slice has been activated. We also see that the service has alarm supervision enabled, so the fault monitoring indications will be sent to MDSO. Right now, the alarm count is all zeros, indicating that the slice is functioning as expected. BluePlanet 5G automation also provides an end-to-end view of the slice. From the topology view, we can see the DU, the mid-haul, the CUUP function, and we have the backhaul, which is a layer 3 VPN followed by the Radisys UPF. We can drill into the backhaul to see the details of the layer 3 VPN between CUUP and UPF. So clicking on the backhaul icon will open the BluePlanet Route Optimization and Analysis product or ROA. ROA provides a topology of the backhaul network. You can see that VPN 001 is using the top path connecting P11 and 12 through P1 and P3 router. Through segment routing and MPLS TE, ROA was able to select the most optimal path with the lowest latency. We are now ready to create a latency sensitive slice. Once again, we go into Create. This time we select URLLC. We enter the parameters for the slice based on GSMA GST and click on Create. We can see the slice creation is in progress. This slice has a new RAN component and a new transport slice, but is reusing the same 5G UPF from the EMBB slice in the core. Let us drill down into the new slice to see its details. The end-to-end topology for the URLLC slice can be seen here. Drilling down into the backhaul shows us there is a new VPN, VPN 002, that terminates on the same PE11 and PE12 routers and follows the same path through P1 and P3 as the EMBB slice we just created. We will now move to the lifecycle management of the slice and activate it as well. We see that the slice has been activated and that the lifecycle management state is in supervision state. Let's go into the second phase of the demo. During the runtime phase of our lifecycle automation, the slice is under supervision when congestion is detected on the backhaul. ROA detects there is a latency issue on the transport network and that is causing congestion. At the same time, through lifecycle automation, MDSO detects that the latency SLA of the network slice is not met. I'm back into the UI. Now the BluePlanet 5G automation solution shows critical alarms coming up and we see something is happening in the transport network for both slices simultaneously. We can see the transport network being impacted and cascading to impact the entire slice. Let's use the drill down options we used before to investigate this issue. Using the end-to-end view for the EMBB slice, we see that there is a critical problem in the backhaul network, highlighted in red. Drilling down into the backhaul takes us into ROA. We can see the VPN 001 used for the backhaul and can clearly see the latency has increased from 1 millisecond to 50 milliseconds. At this point, ROA does automated path computation and executes a recovery path. We see the VPN path changing to bypass the congestion. Despite the new path having a latency of 4 milliseconds, which is greater than the original latency of 1 millisecond, the EMBB slice has recovered as it is a latency agnostic slice. In the final stage, we will see that though ROA through its PCA selected the best path to alleviate congestion for both the slices, MDSO determines that the latency SLA for the URLLC slice is not respected. It therefore instantiates a second UPF instance closer to the edge of the network to reduce latency. So going back into the UI and looking at the slice details, we see that the alarm for EMBB slice has been cleared, but a major alarm has been raised on the URLLC slice. Let us go into the end-to-end topology view. We see a lower level alarm now shown in orange on the transport slice. Drilling down shows that the VPN 002 also has shifted and is using the same recovery path as the EMBB slice. The higher latency is fine for the EMBB services, but it does not meet the SLA for the URLLC slice. At this point, we can fix the latency problem only by modifying the URLLC slice to reposition the UPF closer to the edge and reduce the backhaul latency. Going back into lifecycle management for the URLLC slice, we select modification and apply. At this point, MDSO's policy determines the closest compute at the edge and instantiates a new UPF on that edge compute. We now see resolution of the alarm and that the URLLC slice has recovered. Let us now take a look at the topology of the slice we modified. You can see the end-to-end slice with the new UPF running. Since we have moved the UPF to the edge, it has also eliminated the VPN in the backhaul path, and thus there is no reach when clicking on the backhaul icon. With that step have been completed, we have shown how BluePlanet can intelligently automate the lifecycle management of 5G network slices from end to end. This concludes our demo. Thank you for watching and please do check out our other videos and resources on BluePlanet.com.